Need to get that.
Are we live?
Yes, we are. Hello, all. Welcome to the Baseline Show.
What's up, everyone? We're live.
All right. Yes, today we have an open office hours. We do not have a guest, but we're just gonna chat about stuff that's going on in the Baseline community and in the tech world. We'll see who else hops on our live studio. And we do have guests lined up for the next 2 to 3 weeks, actually, and hopefully for the foreseeable future. So these open office hours will hopefully become the rare meetings. But we're always happy to do them still. I guess what is up, Keith? How is work going in the BRI3 world post Milestone 3 completion and moving on to the ZK work? I know you gave us a walkthrough last time. You ended on a good cliffhanger. That's why I'm pointing to you of in the future, I can show some more code, but I'll let you tell us how things are going and how the next milestones starting to play out.
Yeah, sure. Was that the cliffhanger that I left off on? Did I say that?
That automatically means you're plugged into the next show.
We can always show more code, right? We can always go, I guess, in depth to the design decisions that we made and the trade-offs and like down into the details. I'm not sure if that's what everybody wants when watching the show. I mean, who will it appeal to, like those with the strong technical dev backgrounds? We can always do some more of those, but before I get the chance possibly to go into that, we can talk about, like you said, where we're at. So we had finished previously Milestone 3. We've just started Milestone 4. So currently there are multiple tasks that are being taken up by the members for Milestone 4. I'll go ahead and show some of them pretty quickly. Okay, should be sharing my screen now if you guys can see, right? So I go to the screen a lot whenever we're talking about BRI3, SRI, whatever milestones we're working on. We keep all the issues pertaining to BRI3, inside of just the EA Oasis baseline issues tab here. It's going to be mixed in with, other issues of people working in the open source community. Usually it should be a SRI tag before it. We try to stay a bit mechanical in the way we do things. It's not always the case. Some issues are written off the cuff from things that we missed in previous meetings or things that need to be corrected. So some of them you'll see, like this proposal document. This one's actually written by me, and I didn't put SRI in front of it, so that's my fault. But we can take a look and see on currently the issues we're working on. So right at the top, we have just an issue to remove the create anchor hash API endpoint. So in the work that some of our members, in this case, Shri has been doing, Biswasher has been doing for Milestone 4, which is the more, let's get the system connected to the blockchain that it's able to create these anchor hashes, anchor them on chain, along with a ZK proof and whatever it is that we're using to prove that some state progression has been made. In this case, there was an API endpoint that was made kind of really public when running the system for somebody to create an anchor hash, but there is no point in having this endpoint because anybody who's going to be creating the anchor hash will be doing so kind of internally, right? If we are all members of the same BPI and we are trying to progress the state of whatever it is we're working on, whether it's some kind of like validation of information, validation of purchase order, and then if you submit the correct information and proofs and everything, the system should automatically create this anchor hash, add it to the various storage places, one of them being on chain, right? So there is no reason for an entity, a BPI account or subject to say, hey, here's an anchor hash created on chain, right? So this is a simple, like, somebody was going through the motions and creating all the stuff you need for this anchor hash controller and its internal logic, and they opened up an endpoint that's like a small piece of code. And then we're like, okay, well, this is not really necessary. Let's not include anything that is never going to be used, right? Or shouldn't be used, right? Let's not open ourselves up to the possibility of, something crazy or incorrect happening. And then we go on through and we have things like, so the proposal document on state object CRUD, if you remember or have kind of listened to some of the my previous rantings on how we do the open source work, we always, our group has agreed that, every time somebody takes up a task, they are to originally create a proposal document. And this is just a Google Doc. And the issue, there should be an issue corresponding to that document, right? So I need an issue for, I'm going to create the proposal document for the state object, the CRUD, the create, update, delete, all that other stuff for the state object inside the BPI. So we create an issue to do that. We create the documents. We then, on the time that we meet, which is Thursdays, in case anybody's interested, because by the way, we've had a lot of uptick in people who want to participate. I'd say maybe in the last week, I've heard from 5 people who want to get involved in the open source deving. And I think that really only 3 of them are like hardcore coders, and the other 2 are just like in the economics/blockchain area. So maybe we can also talk about how they can get involved, right?
Research group.
But
yes.
yeah, research group, or I'm not sure exactly what they were imagining. I think they're imagining something more BRI3, helping progress BRI3. So maybe a new research topic, or is that, taking old research and trying to apply it in a BRI3 implementation with what Mark's doing and writing out the user stories and the test case and getting us to the point right where dev can start, or outreach or something else, right?
Yeah, that's a good idea. Like even documentation, of course, or even with the upcoming interoperability use case that's been identified, we're going to need some functional minds in between the use case and the technical requirements. But there's definitely places for them to get involved, or room for them to even give us ideas on what they envisioned they could do, and starting it up for them.
Yeah, I think it'd be really helpful if we can kind of flesh out those roles, because even though, when devs come in, it's easy to say like, oh, hey, here's the project, you get acquainted, you come to meetings, and you start, just working on whatever issues are up. So maybe there's an issues board for things that are not like purely dev, or somewhere in between, where people in the open source can go pick things up and start doing things, right? Because I know a lot of the meetings we have, especially the ones that Mark leads, he tries to leave the meeting with like, hey, here are the actionable items that we all need to do, right? And Andreas as well, or here's the actionable items. So it would be nice if some of those items can, if we have this uptick and people want to participate on a public issues board. I'm not sure where, maybe it'd be in the standards or the blips repo, whichever one, and then we can point people there and be like, hey, you can put your name on this task and start doing it, right? But yeah, that'd be really helpful for giving them direction, right, and how to help. So anyways, once you have an issue for the proposal you're going to make, you go ahead and create that proposal document. We have gathered all of the links to all the proposal documents and issues and everything that we've ever made. I believe it's over in the grants repo. Yoav usually manages that, so I'm sure he knows the exact location. But if you go ahead and click in, this should be open to the public. Anybody can kind of go in and see the form of these. It's very kind of relaxed. There's a general flow. This one is still not totally complete yet, but there's a general flow of, there'll be an introduction, maybe some examples. There'll be a collection of all the requirements that relate to this issue from the standard, the baseline standard. And then below will be kind of a first look at what the classes or the kind of the interfaces for the objects that we'll be working on, right? If you know that, if I know I'm working with these state objects and I can completely say like, okay, based on these requirements, that this state object needs to possess these qualities. It needs to have an ID, it needs to have a prover system, a curve, hash function, witness, state tree, so on and so forth. And the same thing, well, okay, one of these things in here, like a Merkle-proof witness, this is like the type of the witness. Well, it's an object that is also composed of many things, right? It also has an ID, a root hash. So that's kind of the first task, is let's look at all the requirements, all the things we can in the standard, and let's determine what do these objects that are being passed around, what are they made of? What is the state object made of? You know, if it's made of something like the witness, well, the witness isn't just a singular thing. It's going to also need an ID, root hash, so on and so forth, right? So it is not everything that's done in the dev tasks, but it is like the very beginning, the start. If we can agree as a group that all these things, the state object, the Merkle-proof witness, the leaf, are composed of these things generally, then it's much easier to start out. We all have kind of like a consensus that this is what it should look like. Of course, if you have seen me share code before, there's a lot of, in between, right? Not only do we have these objects themselves, right, with these things like ID and Merkle tree and so on and so forth, but then we have these agents that are deciding, how do you handle trying to do something with that object, right? Like I have, let's say, a BPI Merkle tree. Well, how do I actually create that Merkle tree? So the document doesn't just outline, every single thing. It's kind of the general shape of the objects you'll be dealing with. And then it's up to you to go and code, well, how, does the normal agent and the storage agent and the commands get executed kind of, between, right? Then this between is when the information enters kind of from the outside, like I as a subject want to create a Merkle tree or a state object. And then how does that kind of propagate through the system, right? How does that get transformed into something that is going to be put on chain, going to be put in storage, going to be put in a Merkle tree, right? Because as it flows through the system, it's going through its kind of execution process, and it exists ephemerally, right? Ephemerally. So once it's in those storage places, it's really no longer in this ephemeral memory of the system itself. And that if you need it again, you have to reach back out to those places stored and pull it back in as kind of like a virtual object. So all that handling, really it's handling the flow of those things is what you're left to do, right? And then of course, there'll be an implementation issue corresponding. Usually comes after people have said, everybody kind of signs off on the document. They said the one that I just showed, it's okay. All right, well, let's have an implementation issue that kind of says the task. What do I need to implement? I need to have a state CRUD model. I need to actually implement the create, the read, the update, the delete, functionality of accessing these objects and manipulating them. I need that logic. And then I need tests, right? Always have to have tests for basically anything you create. If I create the object itself, how the object's handled. So I need to write tests for those, the functionality that handles and manipulates that objects to ensure that for most of the broad cases we're going to use, we have a test to say, well, it is handled specifically in this way. And we can look at those more as we go through, but that's a general overview of how our process as an open source team, and then I'll just go ahead and read off, I guess, some of these issues. So we have, propose a document for state object CRUD, the one I went through. We have SRI write a happy case end-to-end tests. So most of the things we have right now are unit tests. We don't have any large end-to-end tests yet. So this is a task that hasn't been picked up yet, right? And if you want to join, you can start joining our meetings on Thursday morning, 9 a.m. CST. I think it's 10 Eastern Standard Time. And you can feel free to join the group and then talk and really pick up, this task. It's open. We have things like mocking Prisma in a way that allows us to ditch writing mock storage agents in unit tests. So right now, a lot of our unit tests are using like a mock storage agent, because when you're running the test, it doesn't have the system is not spun up, right? The Docker storage is not spun up, so the test is kind of running outside of the normal execution, so it doesn't have access to those to the place where all the information is stored. So you have to kind of create a mock or example. Like, for example, if I want to test that the state object, you can do all these things with it. Well, if I tell it, oh, go reach out to the database, well, the database is not there because you're running a test that's outside of the normal execution, right? The execution is not even running when I run the test, right? The execution of the BPI. So instead, I have to say, okay, well, let me just, whenever you go to run this test, first, let's spin up like this ephemeral a mock database, which is really just a couple structures in TypeScript, right? Say, okay, here's a state object you can work with here. Let me just give it these default values. Use this when you're running the test instead of trying to like reach out to a database, right? So this is something we're trying to replace with like an auto mocking function from Prisma. Prisma being the ORM, the object relational mapper that allows us to communicate easily with the actual database, right? One of the functionalities of these ORMs usually they'll make available is a way to mock the database as well, right? So that you can do cool things, tests like this. This is the corresponding implementation issue for the state object CRUD. Here's one for parse messages coming in via NATs and create BPI messages that are persisted in the database. That's Ogden's issue, move hard-coded test values. Right? So we see a lot of stuff here. Not all of them are exactly related to ZKP and Anchor stuff, but we'll see like right under here, we have a large flow of them. Merkle tree CRUD, ZKP component, implement the circuit, which is Shree's working on now. Implement state object as input for Anchor hash. So here's a lot of the ZKP stuff that's actually Milestone 4. And then some of these other things are just cleanup and kind of technical debt that we've accrued over time, right? And the idea behind that is, well, maybe we set things up in a way that's easy to run it and given its current status and circumstance, like of the BPI, right? It makes it convenient for us as developers to spin this up in a certain amount of time with like a certain amount of commands and run this thing. But then as we progress and the BPI actually starts to take true form, well, then that kind of like, for example, the mock thing that we were doing before that aids us, it's no longer useful, and it has to be reconstructed in another form that is useful for the stage that we're at, right? Because we're doing all these development stages before we actually get to the true, real, complete thing, right? And so some tasks are related to that. Okay, and then yeah, you go on down through, and I think you'll see a lot of more ZK stuff that are not even picked up yet. For Milestone 4 that we just started.
So Keith, I have a question for you. The state object is a pretty fundamental part of the baseline standard. It's one of the first things that it talks about. Would you mind going back into that proposal and just giving us a little bit more detail about how you and the team are thinking about representing the state object within a BPI, and give us some context on how you're creating the interfaces for this and how it interacts with some of the other parts of the code, and Merkle proof witness, why would you want that? Maybe why would you want to go with a proving system, some stuff like this?
Yeah, sure, I can do that. So I started compiling all this stuff, and then I reached out to Andreas and I just said, hey, you wrote the standard. I've been reading through all this stuff, and I'm like, and I was like, this is kind of what I have so far. But, if you happen to just know already, to also tell me what you think it should, all the qualities it should possess, right? And I just straight up copy and pasted, what he wrote to me right here in the bottom of the document, right above, right? And just to see, like, what does the person who created it believe should be there, And how does that correspond to how I'm interpreting all the documents and everything going on, right? And so, of course, we have the state tree, which in this case, our initial implementation that we agreed on in the group would be using Merkle proofs, right? In reality, it'll probably end up being a Merkle proof inside of a ZK circuit, and that ZK proof will be on chain because it'll just be much more succinct, right? And a lot of this information has to be attributed to the work that this washery is doing. There's another large document that I'll go find in a second that kind of details kind of the overarching steps along this flow, right? So this is only one part in the flow, is let's decide what the state object is, right? So we have the state tree, right, with the root and the hashes and hashes of leaves, and needs a pointer to the storage object of the leaf. So this is updated every time a state transition is approved. A new leaf is inserted on the right or left, in this case, the leaf position. And so this is kind of to track the state itself. Inside of the state object, we have the state tree. So it is a Merkle tree. It is tracking the state itself every time there is an update of the state. So we have a new leaf that's added to the tree. So whatever the state is, whatever it's composed of, when all those things come together, you can imagine that as being turned into like a single alphanumeric hash that's being put in the tree to say, hey, we've taken everything into consideration. This is the new overall state. Let's go ahead and kind of like timestamp it somewhere. Or let's go ahead and let's just like store it somewhere as we know this is the most recent state, right?
You could say that's a new commitment to the Merkle tree, right?
Yeah, you could say it that way, yeah. It's just adding a new leaf in. And so that's what this one thing is here, the state tree, the Merkle tree, which is reliant on, you can see I put here, it's reliant on this Merkle tree CRUD, right? This is another outstanding issue that we had, which is the system has to be able to do the create, read, update stuff to a Merkle tree. It has to have that ability. It doesn't have that ability yet. So that's the one that I'm like currently working on, and which I'm pretty much done with and should be able to PR out today, I believe. So once it has all these abilities, well, then it's easy enough to say, okay, well, let's just create a Merkle tree. Let's put it as part of this object. And then whatever we need to do to it, you know, update it, add leaves, that should all be handled inside this CRUD right here. So this is like essentially a state tracker, right? Then of course we have the prover system. So it's in a lot of ZK talks, and you're going to hear like, well, what prover system are you using? What system used to prove that things are what you say they are, that the state is what you say it is, so on and so forth. For us, again, the first approach is just Merkle proofs, right? Let's just prove that this thing is part of the tree. Let's add this to the tree. Let's prove it's part of the tree, and we can take that proof and we can pass it on really anywhere. Because we want to do it on chain, it's more likely that it's just going to be the Merkle proof inside of a ZK circuit. In this case, I believe Shri is doing that in Gnark. So a Golang like DSL ZK, and so that's going to wrap the actual Merkle proof because of the way that the Merkle proof will grow over time, and it'll be able to wrap. Go ahead.
Yeah, so you're talking about wrapping the Merkle proof in a ZK proof. What does that circuit actually look like? Do you have a generic idea for how you would prove the Merkle proof within a circuit, like the predicates, or
Yes.
Is this a later thing that you guys are thinking about?
No, so I mean, this is something that I don't know all ZK libraries. I know that Gnark comes with this functionality out of the box, right?
Okay.
And it actually already exists in our open source circuit that we have within the consensus mesh repo, right? Is
Yeah.
part of a project that we've done before. Comes out of the box with them. They're always actively deving, so there can be some amount of I don't know, finagling that you need to do to make this work. But for the most part, you should be able to access their API inside the circuit and just say, hey, I want to do a Merkle proof, right? Like it's, the code's going to be like API dot, let me, Merkle proof, whatever. And then it's going to accept a certain amount of parameters that are being put in there. And it will do the Merkle proof for you inside the circuit. So it's not something that you have to construct from the bottom up. But if you needed to, all the tools, would be there. And you would essentially just have to do some kind of take what you've been given, which essentially will be like the root hash. You're going to be given the leaf you're trying to prove that's kind of included in the Merkle tree. And then you're going to be given a path of ones and zeros that represents kind of like left and right as you're going up the tree. Because in reality, right, you're looking at the tree from like the bottom up, right? The bottom leaves and then all the way up to you can imagine it like this as well, right? But a lot of the time you'll see it with the bottom leaves. The bottom leaves are the most recent, and you're saying, okay, this is your leaf here, all right? And you want to do a proof that it actually is included in the tree. You've given this, we have the root hash, which is what we should end up at the end. And then we have the path that's kind of how you travel up the tree. And so essentially you're taking two, kind of hash them together and then getting the next part up the tree and so on and so forth until you get to the last one and you say, okay, well, the root hash that I made based on the leaf and the path should match the root hash that was given. If it doesn't, then something is wrong. The leaf, we just say the leaf's not included, but it could be the leaf or it could be the path is technically wrong, right? But that can be done easily inside of most circuits, because the problem in doing work inside these circuits is that you're limited to the certain math you can do essentially. But as long as you have a circuit safe type of hashing like memc that you're able to, if the tree is constructed with the memc hash, then you'll be able to reconstruct it inside the circuit, right? So as long as you can do the math inside the circuit, in a reasonable amount of time, the same you could do kind of outside the circuit, that you eventually just produce a more succinct, like, okay, we have proved that the math inside the circuit has run correctly, and that math is a Merkle proof of, that your leaf is included in the given tree. So we don't need to provide anything else but the actual ZK proof at that point. And then some way for people to verify it, right? Which can be done, it could be done on chain, right? With Solidity contracts, right? NARC also has, a lot of other ones also have the ability to export the verifier and prove a release to Solidity, but verifier.sol, and then you can put it up.
Yeah, cool.
And then there's a couple other things, right? Prover system. Well, how are we creating the proof? In this case, it's a Merkle proof. What curve are you using? Well, we're not using a curve because Merkle proof, right? If we're doing something else, Groth or Planck, then you'd have to choose some elliptical curve. A hash function. In this one, we're just going with, real standard like SHA-3256. Most of our implementations, the idea is, well, let's just go with whatever something very standard is. And let's make that our first one. And then as soon as we get all that working, then we can make things more dynamic, right? To where you can choose a certain hash and so on and so on and so forth, right? Which is, it's not a terribly difficult task, right? When you think about it like one at a time, but if you start from the beginning and you try to allow it to do all the hashes and the curves, and then it can become difficult because you have to ensure there are certain hashes, like I said, and when you're in circuits and out of circuits, it'll be working and it'll work well and, or optimized for certain things. So instead of worrying about all that, the first idea is let's just make it work with a very standard default case and then kind of expand the system from there. And then you'd have the witness. So the root hash, the Merkle proof, the leaf. In this case, the leaf would be the signed document by the buyer and seller, two SIGs, one over each other, encrypted data used to validate the transition, so on and so forth, right? And I think that's pretty much it. We can see here, proof of system curve, hash function, the witness state tree, and the witness itself is going to be made up of all the things I talked about that you need to construct the Merkle proof, right? Whether it's inside or outside of the circuit, right? You're going to need the root hash to compare at the end and say, all right, well, the root hash we calculated is the root hash that they're saying is kind of the source of truth. You need the, to store the Merkle proof itself, and then, the leaf, which in this case, as you can see, represents.
That's the new commitment, right?
Right. It's the new state commitment to the tree.
The new state
right?
proposal
Yeah.
for the object.
Yeah. And then for us, I mean, it can be many things for many different BPIs. For us, it's just simply, well, this is the document hash, the hash of the document that's representing, the state change. And then, the two entities interacting saying, okay, yeah, we signed off on this thing, right? The state's been passed back and forth. They both sign off. This is okay. Let's add it to the state. And so that's the actual leaf that's being added into a tree. Yeah. And
so the
ahead.
signatures on that state object that you just mentioned, those are hashed with the commitment, right? Is that how we're noticing those two signatures, or how are we picking up on that here?
So in the case of, like, if we get the document and both parties are okay with the document, let's just say, and the document's been hashed, and then both the buyer and seller are okay with it, they'll add their signature kind of one over the other on top of it, right? So like
On top of the leaf?
On top of the thing that will become the leaf.
Okay.
Right. So they're not, it's not the leaves added in and then they sign. It's all these things need to happen before this thing becomes kind of like a commitment to the tree, saying like, this is the new state, right? We need both sides to sign off and say, like Bob and Alice to say, and maybe this is a good time to show the overarching document.
Yeah, let's do it.
We need both sides to say, hey, we have signed off. This is the correct state. Now it can be added to, you can see the Merkle tree almost as like just a storage of things that have happened and we've agreed they've happened kind of correctly, right? And this is a pretty long document that Biswasri has put together detailing everything. Here is a proposed flow. Alice proposes a document to Bob. The initial state of the document is captured in the state object, right? So in the state object in the leaf, there was the actual document itself. The state object acts as a common frame of reference for the participants in the work group. And after updates or changes proposed by the work group participant is finalized, state object containing the document is anchored to the CCSM, right? So once, and that is kind of like skimmed over once all the work group participants have finalized, this document, meaning they signed off on it. And what do that signing really look like? Well, in code, we just decide a cryptographic mechanism for somebody to sign off on this object. And then it usually includes them providing, like, for example, using their private key to create a signature. I'm sure we've all seen like where if I want to send a message, an encrypted message to Mark, or I want to sign to make sure it's from me, I can sign with my private key. Anybody can have my public key and they can say, okay, well, let me make sure that it's you. If you use the public key, the message you got from me is at least signed by this particular private key, right? So depending on how we want to implement, we use some cryptographic mechanism to allow them to sign using some private key that corresponds to a public key account that they have inside of our database. And then once it's finalized, it's going to be added into the Merkle tree. And yeah, so I encourage you to take a look through this document. You not only get a feel for the overall flow of Milestone 4, all the components, state history. You can also see, on the side, the conversations we've been having. A lot of our work is done asynchronously, right? A majority of the work. We meet once a week, maybe 30 minutes at most. And so the majority of work is done asynchronously, right? And this, not only will this document give you a good idea for what BRI3's first implementation of Milestone 4 is going to be with content addressable hashes, on-chain, off-chain state history, the blockchain service, the ZKP proof service inside of BRI3, but it will also give you a good idea of, how to take this in a modular fashion and really implement it in any other project that you have as well, right? It's specific to a lot of the requirements for a baseline protocol implementation, yes. But honestly, if you just look at this part alone, the applications that it has, and getting different parties to sign off on and finalize a state change and to place that, in an on-chain fashion where it can be verified, the implications for many systems, it's quite advantageous, I think. So, yep.
Yeah, that's great stuff. So where can everybody find this overall document that outlines this process? It just through the issues, or is there a larger folder that houses all of these proposals?
Yeah, I'll find it in the other place in a second for sure. If you just go into the EA baseline and scroll through the issues and you find any of them with ZKP on it, Shri will have linked the overall kind of arcing document. I think it's in grants.
I will look. It might be a blip, but
blip made me blip.
yeah, we do have one location where we've been hosting all of the updates, but otherwise they're available in the folders.
Yeah, I think it's blips,
yeah. Let me.
Here,
I'll
this
ping
one
in
in grants is kind of the overall breakdown of different milestones, 1, 2, 3, 4, so on and so forth.
So Keith, these proposals that have been made, do you see them being able to be repurposed for like an implementer's guide? Or I don't know, I feel like you guys did some good work of collecting and putting in considerations for the architecture, or do you think it's not reusable?
Oh, I mean, of course it's reusable.
Good.
Yeah, not only, could it become a just implementer guide for the specific way we've done it, but even with a little bit of kind of generalization throughout some of these documents, or even just, through the minds of any person who is a developer and wants to look at this or is not and say, okay, I've seen what they've done. Let me do my own twist on this. Let me do this instead of Merkle proofs. Let me do it that way, so on and so forth. That it's sometimes as a developer, I don't care if I have a guide that's like, this is the best way to do it, or this is the only way to do it. It's just like, show me a way to do it. And then I'll be able to say like, okay, I want this to be different. That's, anything to guide the way really helps. So it'll definitely, all of these documents together, the aggregation, then will serve well, I think, for that purpose. And yeah, here it is. You're right. It was in blips. Baseline blips, if you just go to, if you scroll on down right there, the third one from the top, number 32, SRI BRI3 overview. And it should be pretty much up to date. There might be a couple missing of like the very newest documents we've created. But generally, Yoav keeps this pretty tight in adding everything in. Actually, you might have everything, I don't know.
Cool. All right. Anything else on BRI3? That was a great walkthrough. I think we can never do enough of just going through these issues and talking about the details. So thank you for that.
Yeah, no problem.
Yeah, that was really good. I think we could do more as more proposals come out.
Cool. Any questions or comments on BRI3 before we move on? All right. What else is up, Mark, Andreas? Any new projects, things you've deep dived into or seen in the tech news world?
I would say watch the space. We have a blog release coming up. This is the one that I actually put in there. And what I do is really kind of compare and contrast all the different, commonly used methods of data sharing, that are in use right now, particularly multi-party when when a certain number of the parties exist outside of corporate borders. How can you share data with them without revealing anything that might get you in trouble or might at least give them a competitive advantage over you, because they now know your pricing lists, or they know your customer list and inventories, anything like that. You want that to remain quiet. So we look at shared architectures, EDI, public and private blockchains, really giving an idea in a non-technical fashion as far as how these are used and what they may be good for, and what some of the trade-offs and some of the challenges that come with adopting these. So watch this space. We want to publish it tomorrow. Is that what I said, Sonal?
Yes.
So watch the space on that. And right now, of course, you've got a lot of stuff in the larger space right now, to where you've got Chat GPT that is really getting a lot of attention right now, and it can write all of our term papers and maybe make marketing materials a lot quicker to spin up and stuff. But the one thing that I look at when it comes to Chat GPT is it does not have the ability to discern what is confidential data or not. And it's certain people have kind of looked at that and said, well, if you want to ask Chat GPT how to build a bomb, or how to, make meth or something like that, that's going to be something to where they're saying, no, I'm not going to teach you how to do that. But what happens if you have perfectly legal but sensitive data that is not meant to be shared by others? Chat GPT right now, I haven't seen that it can tell the difference between the two. So if you're using it, for an AI engine, you're going to need to really train your models to be able to know the difference, and so that you don't, inadvertently reveal something that you haven't. So that's just the one thing that I've looked at. I don't know if anybody else came up with that same impression.
Was that part of your blog, or just something you've noticed about
No,
AI?
it's just something that I noticed about AI, because right now AI is getting so much attention right now, and I keep wanting to tell everybody. I said your AI insights or your output is only as good as the data that you put in, data for ingest. So you want to make sure that if you're making substantive decisions, you want to make sure that that data is uniform, correct, relevant to what you are trying to get an outcome to make a decision around, especially if that decision is going to affect someone's health or their finances or anything else. So
Yeah, one idea I had a while ago, probably not the first time someone had that idea, was verifiably trained AI models under zero knowledge. I think I floated that idea to Andreas, but I think I don't know, Andreas, I remember you having some thoughts on that. I can't remember really what you said about that, but I'm sure there are a lot of people thinking about using ZK for AI. But yeah, it's an interesting concept. Do you remember
Yeah,
Andreas,
yeah.
what you said about that?
Yeah, well, it's like you need a supercomputer to patrol a supercomputer, right? Because it's just, yes, of course you can do it, but it becomes enormously computationally expensive, just because of all the you need to. It's just such an enormous amount of operations that are happening. It just becomes not feasible. Now, on the what is interesting is saying, does this am I generating the same answers that I generated before for the same question? So it's like as a check. Those are type of things where you can think about maybe, or whether they're using, they're using the same models, things like that. But otherwise, it's just way too computationally expensive to do all of this stuff. Takes more computation to verify than to actually train this whole thing. So
Yeah, that makes sense. In other news, the CSI ZK EVM just got released, named Linnea or Linnae.
Linnea, yeah,
L-
I don't know.
There's a
Linnea.
handful of
Lenia.
yes,
Linea.
Linea. Lania.
Lania.
Is that like a take on Linnaeus, who did the periodic table of elements?
I don't know, but there's a handful of French people that worked on the CSI ZK EVM, so that might have some influence.
Yeah, maybe they can join our show one day and help us tell us how they
Understand.
say it. But yes,
Yeah.
that too. Well, well, next week we're gonna host Risk Zero on the show. We'll get the link posted soon, so mark your calendars. They're a pretty cool guest working in the ZKVM world, using the RISC-V framework. And I'll share their site in chat, so you can do some brushing up before the show, and we can find out how RISC-V could be used for the execution framework for a BPI. So tune in next week, and I think we are ready to wrap early on this show. Thanks all for engaging in the conversation. Keith, thanks for the detailed walkthrough. And we will see everyone next week for our guest. Thank you.
What?
Thank you.
All right, thank you.
Yeah, thank you guys.
See ya.
Cheers, guys.